we want to balance this reaction, this redox reaction, in a acidic solution. So what we want to do is identify the elements that are being oxidized and reduced. We have a -1 for the bromine, 0 for the elemental bromine, +3 for the iron, monatomic iron. And this, we will assign a -2 for the oxygen. And by using summation rule, we'll figure out that the chromium is a +6. So we're doing chromium is being reduced and the bromine is being oxidized. What we want to do next is to balance these two elements. So we have 2 chromium here, we have 2 chromium there. We have 2 bromine on the product side, we want 2 bromide on the reactant side. Now with those elements balanced, we can use the oxidation number method for balancing this reaction. We're going from chromium 6+ to chromium 3+. We're changing by a factor of 3, but we have 2 chromiums, each changing by a factor of 3, so a total of 6 electrons being transferred. For bromine, we're going from -1 to 0, but we have 2 of them, so we have 2 electrons being transferred. We need to get the number of electrons transferred to be identical, so obviously we need to multiply the bromine by 3 to get to 6. So we'll multiply each of these factors by 3. We had 2, we turned that into a 6. So now the elements that are being oxidized and reduced are balanced in such a way that we have the same number of electrons being transferred, so we're not going to have electrons showing up in our balance equation. What we need to do now is to balance the rest of the elements, which is oxygen. We need to balance the oxygen now. We have 7 oxygen on the reactant side. We need to get 7 on the product side. We're going to add 7 waters. But by doing so, we have unbalanced, we have added in hydrogen, but it's not balanced, so we have to balance the hydrogen. We're going to balance the hydrogen using H+. We have 7 times 2 or 14 hydrogen on the product side, so we're going to add 14H+ on the reactant side. And this will leave us now with a balanced redox reaction.